Hi there, my name is Henry Wisniewski. I'm an undergraduate student at the University of Waterloo, and I've just completed my thesis titled Integrating Virtual Field Experiences into Undergraduate Geoscience Education to Improve Student Learning. This poster is a summary of my thesis, which I completed with Drs. John Johnston and Jem Parks of the Department of Earth and Environmental Sciences. As an introduction to this thesis, in late 2019, the University of Waterloo's Department of Earth and Environmental Sciences received some funding to explore the implementation of virtual field experiences, or VFEs, into their undergraduate courses. I was hired as a co-op student at the beginning of 2020 to help facilitate this and determine as sort of a proof of concept how VFEs could be used to help our students become more competent geoscientists. As part of my co-op, I completed a pretty extensive literature review of VFEs and their benefits and best practices of design, which I've summarized here. There are two key findings that are important for this thesis. The first is that VFEs can be used to develop geoscience-related skills, and the second is that VFEs can be intentionally designed to have students achieve different learning outcomes of different assignments. This information has provided a strong foundation for the hypothesis of this thesis, which is that VFEs can be used to help students achieve course learning objectives and develop their geoscience knowledge. As for the objectives of the thesis, VFEs were implemented in two different courses. The first course, Earth 121, is called Introductory Earth Science, and in this course the objective was for students to be able to think more like geoscientists after having viewed a specially designed virtual field experience. In Earth 231, Mineralogy, students would successfully complete an assignment where the traditional field component of the assignment would for the first time be replaced with a virtual field experience due to COVID-19 related travel restrictions. The methods section of this thesis outlines the design, assessment, and analyses of VFEs in each of the two courses. In Earth 121, Dr. Johnston, Dr. Parks, and myself created a VFE about salt, which consisted of some 360-degree photospheres containing points of interest with additional text and 2D images. Students completed a quiz worth 3% of their overall grade based on the content of this VFE. The quiz responses from students provided both qualitative and quantitative data. In Earth 231, Dr. Parks and one of her TAs created a VFE containing high-definition panoramic images of rock outcrops. These outcrops were visited by students in person in previous terms instead. However, this wasn't feasible due to pandemic travel restrictions. In small groups, students used these panoramas to complete a mapping assignment that was worth 25% of their overall grade. Their performance, as marked by Dr. Parks, was done using an existing assignment rubric, and this provided valuable quantitative data. Regarding the quantitative data collected from Earth 121, so the first quiz question that students completed was a knowledge-based matching questions, which had students match 7 terms and 7 definitions that all related to the content of the SALT VFE. The figure 2 bar graph on the left in this results section shows the breakdown of the 2 most common terms to which a given definition was matched. The correct match, which is indicated by the green portion of each bar, was also the most common match for each term definition pair, which was good. The right bar graph, figure 3, shows the distribution of student marks out of 7. Almost 2/3 of students correctly made 7 matches, suggesting that most students did achieve the intended learning outcomes of the VFE. It's also worth noting that because definitions available to be matched were single use, and there was an equal number of definitions and terms to be matched, it's likely that the success of students was favored by the structure of the question. That is, being easier to discern right and wrong matches as definitions were made. As for the qualitative results of Earth 21, the leftmost pie graph in the results and discussion section, which is shown in figure 4, shows the results of question 3, which asked students to describe the ways in which they felt that they were able to think more like geoscientists. The distribution across each of the 4 ways of thinking was relatively even. We saw 24% of students reported that they experienced improvements to their temporal thinking, 23% to their systems thinking, 23% to their field thinking, and 21% to their spatial thinking. The pie graph in figure 5, so the pie graph on the right in the results section, demonstrates the distribution of sudden moments of insight or comprehension that students reported having experienced. Students mostly reported moments of insight that were related to either the processes of salt formation or the scale and depth of mines. As for Earth 231, the results from this course were purely quantitative. Students were responsible for creating a map and interpretation of the geologic history of an outcrop. This was the assignment that they had to complete. And in previous terms, the outcrops were visited by students in person. However, as mentioned, this portion of the assignment was replaced with a VFE due to the travel restrictions. There were Of all of the different rubric categories that students were marked on, there were 6 categories that were identified as having the most potential to be impacted by this change from a field trip to a VFE. In the figure 6 box and whisker plot, each pair of boxes represents one rubric section, one box for the class marks from 2020 that used the VFE, and one box for class marks from a previous 2019 term where the field trip was used to complete the assignment. Figure 7, the table to the right of the box and whisker plot, contains information from a t-test performed on each rubric section pair. The t-test table tells us that while the grades between the 2 terms aren't identical, they are close enough to be considered statistically similar. And what this means is that any difference in marks between the 2019 class that used the field trip and the 2020 class that used the VFE, the difference between those 2 groups in marks is small enough to be considered a result of random influence. This is true for each of these 6 rubric categories identified here, except for one, and that one is the map element section. So while creating their map, students also needed to properly create and format legends, symbols, and scales, and these were considered to be map elements. The t-test for the 2020 and 2019 term showed that the 2020 class, who used the VFE, performed much better in the map elements section than the 2019 class who used the field trip. In conclusion, to wrap things up, Earth 121 students were able to successfully apply their geoscience knowledge learned from the SALT virtual field experience, as shown from the quantitative matching question results. These results may have been influenced by the structure of the matching question and available resources, or available responses rather. Students reported overwhelmingly being able to think like geoscientists relatively evenly in each of the 4 ways of geoscience thinking. Suggesting that VFEs can be intentionally designed to facilitate specific and multiple ways of geoscience thinking. Students experienced moments of insight, mostly related to locations or processes that they would otherwise not have experienced in person. So, for example, in the tour, the Great Salt Lake was one of these places, as well as the underground Godrich mine. As for students in Earth 231, those that were in the term that did use the VFE to complete a mapping assignment earned overall, holistically, statistically similar marks compared to those who had used a field trip. What this suggests is that VFEs can be used to achieve specific assignment learning outcomes. However, they can't be used to replace fieldwork entirely. Because fieldwork provides students with valuable experience and skills that are greater than the scope of just a single assignment. Significantly higher marks were earned by students in one specific section of the assignment, which was the formatting and creation of their map elements. We think that this is likely related to an added lab exercise in 2020, which students benefited from that they did not in the 2019 term. This lab exercise in 2020 had students practice and receive feedback on creating map elements prior to their mapping assignment that they used the VFE for. And finally, VFEs are engaging and they are able to be designed to facilitate learning when supported with good pedagogy. It's critical that VFEs are designed to integrate course learning objectives to be effective. Thanks very much for listening. Please feel free to more closely examine this poster or have a look at my thesis for more information.